Good morning, everyone. Today we're going to do part 3 of chapter 7, which is types of reactions. Some of these types of reactions we've already covered, and they're just more in depth, and some of them are brand new. So we're going to talk about writing acid and base reactions, writing and identifying gas evolution reactions. Actually, we're just going to identify those. We're not going to write those. We're also going to be able to identify redox reactions, identify and write combustion reactions, and then classify those chemical reactions that don't fall under one of those other types. So acid and base reactions are the first ones. They are reactions that form water. I do want you to note this is liquid water. And it comes from an acid. Remember, acids all start with H. And a base for now is always going to have OH at the end. Okay, I do want to let you know a salt is whatever is left from using the water. The H and the OH, that's what make the water, and then whatever's left is the salt. Acid-base reactions can also be called neutralization reactions. Okay, and they're neutralization reactions because they make water, and then again, whatever's left. It would also be good if you write down the net ionic equation, because the net ionic equation for acid-base reactions is always the same. It will always yield a hydrogen ion, a hydroxide ion, and it will always make liquid water. So you don't even have to write a complete ionic if you know it's neutralization or acid-base reaction, because it always yields the same net ionic. So again, make sure you write that net ionic down. Okay, so you shouldn't need to write these down. Again, just remember acids all start with H. You are going to need to kind of familiarize yourself again with the naming. Remember, that was chapter 5. As far as bases go, again, they're OH. And you just name them like generic ionic compounds, the metal, and then hydroxide, which is that polyatomic OH. All right, so now we're going to start writing a few. We're going to do nitric acid, which is HNO3, which is aqueous. It tells us that. And calcium hydroxide. Again, remember, you need to refamiliarize yourselves with the names. Okay, so remember, it always makes liquid water. And those, again, those come from H and OH. So what I have left is calcium and nitrate. Now, you may be wondering why I put nitrate in parentheses. It's because calcium has a 2 charge that crosses down. So don't forget about those. Also, we're going to need to balance this. I've got 2 hydrogens on the product side, but I've got 3 on the reactant side. And I've got 2 nitrates on the products, but only 1 on the reactants. If I put a 2 there, that fixes my nitrate. That also gives me an even number of hydrogens on both sides. So now if I just put a 2 there, that fixes my hydrogen and my oxygen. Again, if y'all have questions, please let me know about any of that. As far as net ionic, again, remember, it's always going to be the same net ionic to make water. If any of you are at home watching this, you need to reach out so we can schedule a tutoring time, okay? All right, we're going to do one more. I've got sulfuric acid, H2SO4, and potassium hydroxide. Remember, they make water in the liquid form. And then what is left is potassium and sulfate. Again, that 2 came from sulfate charge. We are not balanced. I need a 2 for potassium, and then I've got 4 hydrogens on the left, so I need 2 to make it 4 on the right. Again, our net ionic will always be the same. Okay, so now we're going on to gas evolution reactions. I do need you to understand, all I need is for you to be able to recognize them. So here, gas evolution means it gives off gas or it's a product. Okay, so for now, all you have to do is recognize, yes, that's a gas evolution reaction. Okay, again, there's our gas, gas evolution reaction. That's it. You just have to be able to recognize them. Okay, so we're not going to write them. We're going to skip through all that. Going back to acid-base reactions, most of you should know that the stomach is got acid in it, but sometimes if you have like acid reflux or heartburn, things like that, you've got too much acid in your stomach and you need to take something called an antacid, which is a base, and it will counteract that extra acid. So like Tums are the most common, but there's also other products out there. Next type of reaction is redox reactions. We did talk about these briefly when we talked about oxidation numbers, but it's been a little bit. Okay, so those are reactions that involve transferring electrons. Also remember, we did talk about oil rig. I also believe we talked about Leo says GER. You need to pick one of those acronyms, and then that tells us the other two things. So oxidation is loss of electrons, reduction is gain of electrons. And you can see that with both acronyms. Again, just keep one. You pick which one you want to use. Okay. As far as redox reactions go, recognizing them will be fairly easy, but it's going to be after we learn the other types of reactions. Generally, though, redox reactions have elemental oxygen, so that's O2 as a gas. Okay, also it's going to be a metal reacting with a nonmetal, and they're going to be separate elements, like a metal alone and a nonmetal alone. Okay, they always involve transfer of electrons, but sometimes that's hard to see. I do want you to go ahead and add that it's everything but double displacement, which we're going to talk about in a minute. Okay, but these are specifically going to be those precipitation reactions and those acid-base reactions that we've already talked about. All right, so here it's just a matter of, do we see a precipitation reaction or do we see a acid-base reaction? I do see B is acid-base, which means it is not redox. Everything else qualifies as redox. So here's another one. Precipitation or neutralization is what we're looking for. This C is precipitation because of that solid product. And so all of the rest of those are redox except C. All right, as far as combustion goes, remember we already talked about combustion. The biggest thing you need to know here is that they're exothermic, which means that they emit or give off heat. So heat is going to be a product. Remember, combustion normally involves fire, so it gives off heat from a fire. That's why we start fires in the winter when it's cold. Okay, also remember the generic reaction for combustion. The only thing that changes is that hydrocarbon at the beginning and then the balanced reaction. The rest of it stays exactly the same. And again, we've already seen these. I do want you to remember, while these make water, their water is a gas. If it is a neutralization reaction, they make water as a liquid, and they're very different. All right, so we're going to write a couple combustion reactions. It told me liquid methanol, methyl alcohol is what it says. Okay, remember O2 is always a reactant, and it always makes carbon dioxide and water. Okay, we do need to balance it. Remember, with combustion reactions, I talked about this in part 1, it is always best to start with a 2 in front of the hydrocarbon so that it's easier to balance. So now I have 2 carbons, I need a 2 in front of my carbon dioxide. And now I have 8 hydrogens, I need a 4 here. Don't forget, you have to go back and count those oxygens so you can put a coefficient in front of oxygen. So I've got 4 oxygens there, and I've got 4, which is 8. But I've got 2 there, so I only need 6, which means I put a 3 in front of O2. Let's do one more. So C5H12, and that's liquid, plus oxygen, yields CO2 gas, and water as a gas. It will always tell you the state of matter of the initial hydrocarbon. Okay, don't forget, we're going to start with a 2 there in front. So I have 10 carbon, so I'm going to put a 10 there. I did put that slash through the 0, so you know it's a 0, not an O. I'm going to put 12 here. Then I've got 20 and 12, which is 32, so I need 16 here. The thing with this one is everything is even. Once they're all even for the coefficients, you can reduce them, and you just do that by dividing by 2. Okay, it is much easier to divide them all by 2 at the end if you can than it is to do everything, get to oxygen, and have to come back. That's why we start with a 2 in front. If you have questions on combustion, please let me know. All right, so we've got these new reactions. Combustion, remember, is redox. All of these are not redox because these are double displacement, which is going to be talked about on the next slide. All right, so I do need you to write these down, the different types of reactions with their generic equation. So you're probably going to need to pause the video to do that. As far, again, as double displacement, you will need to be able to do these 4 plus combustion. And then as far as double displacement goes, this also includes acid-base and precipitation. So you'll need to be able to identify all of those types of reactions on your test. All right, so in synthesis reactions, the 2 elements or very small compounds become a larger compound. Decomposition is the opposite. A big compound breaks into 2 elements or into 2 smaller compounds. In single displacement, one element displaces the other from the compound. So here we see zinc as a solid. It's with copper chloride. And what happens is the zinc becomes part of the solution and the copper stands alone. So the biggest thing with these is that you see 2 elements, one on each side, but they're completely different, and then 1 compound. That's how you know it's that single displacement reaction. And the last one, again, is that double displacement reaction. And again, you need to know, yes, precipitation and acid and base fall into that. Also, you need to remember the cations, or the first elements, are the ones that switch spots. Okay, here's just a flow chart. Again, remember, combustion, you also need to know, is a generic type of reaction. Okay, so here we're briefly going to go through what type of reaction they are. This does not include combustion. So A, that is synthesis, and that's because there's 2 compounds making a larger compound. B is double displacement, and specifically it's precipitation, and that's because we've got this solid barium sulfate. Okay. C is single displacement, and that comes from a single element on both sides. D is decomp, and C is synthesis. Okay, E is synthesis. Synthesis and decomposition are the opposite, so it's just them flipped around. Okay, if y'all have questions, please reach out. This one's just going through a real life scenario with ozone and the ozone depletion from our chlorofluorocarbons, which we talked about in chapter 6. But it goes through multiple types of reactions, which is why it's kind of showing you that here. If y'all have questions on any of chapter 7, just reach out, okay?